graph x squared over 9 minus y squared over 25. Now, this is a conic section, and there's going to be three main types that you're going to graph. Two of them are going to look like this, where you have an x squared over a number and a y squared over a number. But the key thing here is we have a minus in between, and that tells us that this is a hyperbola. Now, a hyperbola in this function, or in this form rather, where x squared subtracting the y squared is going to look like this. I'm going to compare it to this. X squared over a squared minus y squared over b squared equals 1. Now, this is about as basic as it gets. The fact that it equals 1 makes life a whole lot easier. If it didn't equal 1, or if they didn't look like this, I'd have some work to do, but that's going to be for a later unit. When you have the x squared minus the y squared, this is going to be called the horizontal hyperbola, and we'll see what that looks like graphed. When given this information, you are going to have vertices that live at plus or minus a 0. You are going to have what's called co-vertices, we'll explain what that is in a second, at 0 plus or minus b. We're not going to worry about foci when graphing these things. I'm not going to lose any sleep over it, but what I am going to do is I'm going to write out the slant asymptotes, which is found by using the equation y equals plus or minus b over ax. All right, now let's find out what my b and what my a are. Okay, again, the original function is given to us as x squared over a squared. So if a squared is 9, taking the square root of these makes a 3. So my vertices are going to be positive or negative 3, 0. Similarly, this is going to be my b squared because it's underneath y squared. So if b squared is 25, then b is going to be 5. So that gives me co-vertices at 0 plus or minus 5. Now that I know what my a and what my b are, that gives me slant asymptotes at y equals plus or minus b over a, which is 5 over 3x. 5 over 3x. 5 over 3x. All right, vertices at negative 3, 0, boop, and 3, 0, boop. Co-vertices at 0, 5, boop, 0, negative 5, boop. Now, the co-vertices when graphing really isn't that important, but what it does is it helps me develop my slant asymptotes, and I can kind of create a box that will help me draw the path that my hyperbolic function is going to go through. Okay, I said what my slant asymptotes were. They're the equations 5/3 x and negative 5/3 x. So up 5 over 3 is going to look like this. So my box over there is kind of helpful. And the slant asymptotes guide what the behavior of my hyperbola is going to do as I graph them. Okay, it's basically just a guide. All right, now on to the graphing part, which is the fun part. Okay, when I have these guys, my hyperbola is going to go through the vertices and kind of follow along this path right here. So I'm going to try to draw you going along this path, and I'm going to try to draw you going along this path, and I'm going to try to draw you going along this path. That looks bad. And I'm going to try to draw you going along this path. That looks better. But the purple guy is my hyperbola. Okay, so it's basically, a hyperbola is basically like two parabolas opposite of each other facing away from each other. But that's what this guy looks like, given the fact that we had the x squared minus the y squared. We had the sideways hyperbolas. If it was flipped around, it would be like that. But yeah, fun stuff.